So this is me. My name is Larkin Greene, and I've been working with adhesives for the better part of 30 years, the last 20 of them with Vettec. But I'm going to try and present a non-biased viewpoint on the adhesives that we use in our industry, which is basically two. And so we're going to talk about the handling characteristics, the heat cycles, and the moisture concerns. So it's going to be kind of nuts and bolts on both materials. But before we even talk about adhesives, we have to ask a couple questions first. Number one, what are we trying to accomplish by using adhesives? Are we trying to repair something? Are we trying to correct something? Are we trying to protect something? Are we trying to glue something on? Are we trying to treat something and protect something at the same time? Are we trying to fix a horse at the skeletal level, which I've done? Or are we trying to do something completely outside the box that has nothing to do with a horse? So all of that comes into play, and you really need to figure out what is the goal, what are we really trying to accomplish. We also want to know, are the conditions right for using adhesives? It's not always the right thing to use, and unfortunately, when these conditions exist, we try to use adhesives because there's really not many other options. But if you've got frigid weather, sub-freezing, you really got to think about it because there's a lot more to think about when you're using adhesives in that kind of environment. If a horse is going to be standing in this after you put adhesives on, you might as well not even do it because it's going to come off. Force, you've got to consider what forces. Is there going to be excess force? And we run into that quite a bit, actually. And then also, what is the pathology that exists on the foot? All of these things could actually preclude us from being able to use an adhesive successfully. And there's nothing worse than following all the steps and doing everything you think is right and then having it just fall off anyway. So we're going to talk about those issues specifically. Then we also have to ask ourselves, do we have the necessary skills? Dumping glue is not a difficult concept. But we still have to balance the horse. The horse has to be balanced to its conformation. And so there's a lot more to it than just dumping glue on or having something stick. So we want to know, do we have the necessary skills? Do we know all of the different materials and manufacturers and what their directions are? They're packaged differently, they're used differently, and so you need to know something about those systems. And then who can help? Unfortunately, one of the biggest causes of failure in the adhesive world is we don't necessarily do it that often. How often do you glue on a shoe? If you specialize in that, or if you're a veterinarian that does a lot of that kind of thing, you're doing it all the time. But for most of us, we're gluing on a shoe maybe once every 6 months or so. And so you'll find that if you're not using a lot of adhesives, you have to get through that learning curve repeatedly. And sometimes it's like starting over, every time. And so if you understand the characteristics of the adhesives in general, you'll have a lot more success. But you really need to think about all of that before you actually, start applying it on a horse. Okay, so handling characteristics, we're really talking about two materials here. There's a reason that epoxies and cyanoacrylates, which is basically super glue, are not used in our industry. Our industry is really unique because we've got impact, we've got load, we've got stress and strain, and so that takes a unique material to be able to do all of those things and do it well. And so we're really talking about two materials, polyurethanes and acrylics. Polyurethanes have been around not as long, but almost as long as acrylics, and acrylics have been around since the 30s. They started developing some of these materials. Acrylics, the official name is, they're called methyl methacrylates, methyl ethyl methacrylates, methyl vinyl methacrylates, polymethyl methacrylates, but basically methacrylate is acrylic, and that's what we call it. But in the chemical world and the adhesive world, it's methacrylate. And so polyurethanes, most people recognize polyurethanes are kind of the cutting edge in adhesive technology, but polyurethanes have been around since the 40s. It's not a new material. There's quite a bit of variation in the way that you can tweak the formulation to have it accomplish what you want. But there's advantages to both of these. So even though I work for Vettec, I've used these other materials a lot in other industries, and so there's good and bad on both sides. So number one, this is no longer really true. It used to be that acrylics were only hand mixed. You mix the powder liquid in a cup and you stir it and you spread it on where you want it. Whereas polyurethanes have generally always been auto-mixed, and one of the primary reasons for that is that they set so quickly. So, and that's really a huge advantage to have something that sets in 30 to 60 seconds. But that doesn't necessarily mean that it's a better material. Sometimes the working time in acrylic gives you time to think, time to make mistakes, time to actually apply something and not have it all of a sudden being setting before you think it's going to. So the fast set is generally more accepted, but there are times when a longer working time is beneficial. We'll talk about that a little more. And then here's one of the big ones. Polyurethanes, one of the reasons polyurethanes have sort of taken over the adhesive world in a lot of other industries too, like your spray-on bed liners. Almost all the bushings on your cars and trucks are made out of polyurethane because it's a more durable material, and you can vary the formulation to where it can be as flexible as like a wetsuit, or it can be as hard as concrete. It's just in the way it's formulated. But one of the reasons it's become such a popular material is because it has very high tensile strength and high compressive strength. And tensile strength is the strength of not being able to pull something apart. That's tensile strength. Compressive strength obviously plays into our world because we have load and we have compression on the material itself if we're gluing on a shoe or if there's a repair that involves weight bearing. So compressive strength is really important. These two materials actually can achieve the same strength in those two categories. It's just that you need a little more acrylic to accomplish that. So polyurethane's much higher strength, but you can achieve that same strength with acrylic. You just have to have more mass, more bulk of that material. And then this is one of the other reasons that polyurethanes have become popular is because they have very low volatile organic compounds. In other words, no vapors. Acrylics outgas. They have you know that smell. If any of you have used it, you know that smell. That's outgassing. Just like when you paint your wall, your room smells like paint for a while until those solvents evaporate and the paint is cured. So it's the same thing. It requires that outgassing in order to chemically set the material. So the danger in that is I would not use acrylic without having a fan near me, blowing fumes away. It's one of those things where they say, well, there's no real evidence that this causes cancer, and there's not a lot of serious health problems, but the people that use this, the highest usage of this is in the denture industry, making the pink part of a denture, and they have very high cancer rates in those labs. And so actually OSHA came in and required them to put in these air moving systems so that it would vent that stuff off. In our world, it's not that big an issue unless you were working in a real closed area, but I would certainly want to have a breeze blowing those fumes away. I've worked with that material enough to know that it can give you a nasty headache in about 15 minutes. And it's not something you want to breathe, for sure. And then polyurethanes are not flammable. They're not considered flammable. You can throw them in a fire and they won't flame. Because of that outgassing, acrylics are flammable, and they have a fairly low flash point. So again, you don't want to have any spark. You don't want to be running your forge because the vapors will ignite as well as the material itself. So just use caution, and it's not difficult in our industry to have airflow and to keep flame or spark away from the material. Okay. So the heat cycles, both of these materials generate heat, and they call that exotherm. That means it gives off heat. And so when both these materials are mixed, the process of exotherm is what actually allows them to polymerize and set to the desired consistency that it was designed for. So the key difference here is there's two different kinds of exotherm. So polyurethanes have what's called a front cycle exotherm, and what that means is that as soon as the material is mixed, it gets hot immediately. There's a heat spike, and then the heat begins to dissipate around 4 minutes. It starts to dissipate pretty rapidly. By contrast, back cycle exotherm means that the material ramps up to its peak temperature over a period of time. And so if you're doing a repair, a big resection, and you're using these materials and you're up against sensitive lamina, you have to be aware of the duration of that heat cycle and how much heat you're actually putting on that foot. The equine foot is very capable of absorbing and dissipating heat just because of its moisture content. But you still have to be careful. And what's true of both of these is the more mass you have, the more of it you have, the hotter it gets. And so this is what we have to think about when we're doing, especially large-scale repairs. Even gluing on shoes on very short feet or compromised feet, you got to be really careful. And so you just need to be aware of these heat cycles. And especially the more mass you have, the greater the heat. And so the golden rule is if you're up against something sensitive or you're not sure, you go in layers. And generally 2 layers is enough. Once you lay down an initial layer and that cools, then you can bulk on top of it without transferring heat to the foot because you've got the first layer acts as a heat barrier. Okay, so this is one of the questions that we get a lot. Do adhesives trap moisture? And the answer should be no. If everything is approached properly, they should not trap adhesives, or they should not trap moisture, I'm sorry. But sometimes they do. There are situations when they do. So we'll take a look at what's the difference between yes and no. But first of all, we have to talk about moisture balance. So we know that feet in a wet environment swell up, they expand, and all the connections get a little weaker from that expansion. Dry climate, feet get hard, compact, tight, and usually pretty durable. So a lot of people don't realize where moisture comes from, and actually very, very little moisture in the horse's foot comes from the environment. It comes mostly from the blood supply. 90% of it comes from circulation in the foot, which is why circulation is so critical in the foot, because if you starve a foot from circulation, not only does blood circulation produce all the tissues of the foot, but it also hydrates the foot. So if you've got a big resected area, that foot is losing moisture. And when the structures of the feet lose moisture, they shrink, they become less functional. And so the idea behind how do we balance moisture is a pretty broad topic that you could bat around for a long period of time. But basically we're either trying to keep feet out of the wet or we're trying to moisturize and put moisture back into the foot. So let's take a look at the difference between yes and no on this. So preparation, just like painting, it's 90% preparation and 10% application. And it's the same with preparing to use adhesives. Preparation is so critical. So you got to think about the 3 Ds, and they are debride, disinfect, and dry. Okay? Every adhesive that's made except for one, which we don't really use, the directions say, clean, dry surface. Remove anything loose or flaky or unattached. So that applies to everything that we do as well. So debriding, you're getting rid of everything that's loose, everything that you don't want, that's not well attached, that may have bacteria in it. And then because we can't see bacteria, you still, because most bacteria on a horse's foot is anaerobic, if you cover up bacteria with adhesive, you've just created the environment that it loves. And so, a lot of this bacteria will just rage underneath a repair, say. And so you have to be really careful. Unfortunately, we can't see bacteria, but you can, if you do some diligent preparation, you can disinfect an area with, toothbrush and some betadine or various other disinfectants. The only critical part is anything you put on the foot, if you're going to bond in that area, you got to get it off of there. You got to get the residue off. And most of the time, just a wire brush is good enough for that. And then, of course, drying. Drying is the #1 step for every adhesive application, even on the wall, which can be fairly impervious to wet. You still got to dry it. And so we use a heat gun or a propane torch to accomplish that. And if you do all that, then you can actually, an adhesive application can actually help maintain moisture balance in the foot by not having exposed sections. Like I said, you've got a big resection, there's moisture evaporating off of that foot, so that foot is drying out. unless it happens to be standing in, mud. Okay, so there are situations where adhesives do trap moisture, and mostly it's because of this. Because if you prepare an area poorly, the bond is not going to stay as well, and if the bond or a portion of the bond releases, now you've got a moisture trap. Now you've got stuff that can get underneath it and set up shop, and you certainly don't want that. So a lot of it is in the preparation, also excess moisture. If you're going to glue something on and then the horse is going to go out and stand in an irrigated pasture, well, that's kind of shooting yourself in the foot. It could be a waste of time and money to do that. And unfortunately, we get a lot of calls for, my horse is, in the wet environment. How do I, put adhesive on to keep the moisture out? And so that's a real challenge, because if you can get it on there, prep it, get it on there when it's dry, then excess moisture is not as big a factor unless they're standing in it. If they're, wading through creeks, walking through wet grass, that's not going to have an effect. But if they can stand in something that submerges the foot, then you got a problem. And then again, it's insufficient mass. If you put adhesive on, you spread it too thin or you dress it too thin, it doesn't have the strength, and it's more likely to become unbonded. And unfortunately, a lot of these things, they don't just become unbonded. Parts of them become unbonded, but they still stay there. And so then if they're in an unclean environment, now you've got a trap. And so you really want to avoid that. Okay, so if you follow, all the directions, and different manufacturers have different directions. Follow the manufacturer's directions, and things should work out. And there are certain things with adhesives you should not do. I think you could, in this country, you could certainly get a ticket for this. But you just want to try and avoid doing stupid stuff, unless it's on somebody else, and then it's just plain funny. If everything goes well, adhesive should do what you want it to do. So, how are we doing on time here? Okay, questions? No questions. Oh. Yes. Yes. Super fast is hotter than adhere. And generally, where poly, thank you. Is that does that mark the start or just the exit? Okay. Bye-bye. Yeah. Yeah. Thanks.